Hello, this movie is for Learning Target 5. Find the areas of circles, sectors, and segments. Area of a circle is pi r squared. So when we have a circle, the radius is halfway across. We square the radius and multiply by pi. Go ahead, pause the movie, find the area of this wrestling mat, and press play when you finish. Okay, because we have a diameter of 32 feet, that gives us a radius of half of that. And so area is pi times 16 squared. Or 16 squared is 256 pi feet squared. This would be our exact area. And it's exact because we didn't type pi in. If you type pi in, you'll get the rounded approximately 804.25 feet squared. So this is approximate versus the exact. Now, a sector of a circle is a region bounded by an arc of the circle and two radii. So right here we have this colored part is the sector. So we call it sector RPS. Notice it extends from a point to the central angle to the other point. This sector is just like pieces of pizza. So perhaps sector RPS represents 2 or 3 slices of pizza. And what we're going to be able to do here is find the area of this sector. And what you notice is this area is just a fraction of the entire circle's area. So we're going to find that fraction by taking the central angle, whatever that angle is, out of 360. So let's say that that central angle is 60 degrees. Then I know that 60 out of 360 represents the fractional angle that's in this circle times pi times radius squared. So all we're doing is taking the area of the circle and then multiplying it by its fractional part. That fractional part is the area of the central angle out of 360. So this formula here should make a lot of sense. Area of a sector, AOB, is the measure of arc AB, which is equivalent to its central angle, whatever that angle is, out of 360 times pi r squared. So let's do this example here. We have that the arc GH is 72 degrees, so our central angle is 72 degrees. And because of that, this sector that's shaded is 72 out of 360 total. That's our fractional part, times our radius, 15 squared, times pi. Now, pi being an irrational number, if we type everything else in, then we'll get an exact answer and leave our answer in terms of pi. So this will give us 45 pi centimeters squared. So we say the area of this sector is 45 pi centimeters squared. Okay, let's see this one. We've got a circle. And we've got that the circle has a radius of 4. So we've got 4. And what is the area of a sector bounded by a 65-degree minor arc? So let's see if we can get 65 degrees. We've got another 4 here. And let's get the area of the shaded part, which would be in here. Go ahead, pause the movie, try this on your own, and press play when you're finished. So we have that this piece of pizza or a piece of pie or a piece of cake, whatever it would be, is 65 out of 360 times pi radius squared. And if we type everything else in except for pi, we'll get, 65 out of 360 times 16 gives us 26 over 9 pi inches squared. And this is about, and that's exact, because I know that that's going to give me a decimal. This is about 2.8 repeating pi inches squared. So you could have either of those if you represent the 0.8 repeating. Okay. So that's how you do a sector. Now, before we move on to segments, what I want you to do is to learn a new formula for the area of a triangle. We know that SAS stands for side angle side. So in this case, if we've got side A length, side B length, and angle C, then we can use something called a side angle side area formula for a triangle. And the formula is this. Multiply the two sides times the sine of the included angle divided by 2. So, what are two other side lengths and angle measures that could be used? What if I knew angle A? Then I would use B and C. So my area formula would be side B times side C times the sine of angle A, all divided by 2. Well, what if I know angle B? Then I would use C and A. So area over here would be C times A times the sine of the included angle, all divided by 2. So we're going to practice this because this is going to be the easiest way to get the area of a triangle doing this next section. So let's practice this before we do segments. So here we've got a triangle. We've got the two side lengths with the included angle. So it's basically 6 times 4.8 times the sine of the included angle divided by 2. Type that in. You get 10.7 inches squared. So this is a new quick way to get the area of a triangle. Pause the movie, try doing these two, and press play when you finish. On this first one, we've got these two sides, and because I've got those two sides, the 57 is my included angle, so I'm not even going to use the 63. So my area formula is going to be 10 times 15 times the sine of 57, all divided by 2. So the area of this triangle is going to be 62.9 centimeters squared. Then on this one, I've got all three sides, but only this angle. So I'm going to use the two sides that form that for side angle side. The area is going to be 9 times 21 times the sine of the included angle, all divided by 2. So we type that in and we get 33.9 millimeters squared. Okay, we're going to be using that method to find the area of a triangle. Now back to circles. This part right here where you have a chord and it cuts it so that we've got this little shaded region here. This is kind of like the crust of the pizza. That is called a segment, which I think is a very strange term for it, but it's called a segment of a circle. How do you think you would find the area of this guy? It definitely is a fraction of the circle. But basically, if we form a sector first, we could get the area of the sector, subtract off the area of the triangle that you have, the triangle being right here, and that will give you the area of the segment. And that is listed here. Area of the sector, subtract the area of the triangle will give you the area of that segment. So let's give that a try down here. What is the area of the shaded segment shown at the right? Here we go. Now, this radius is 18. This is also a radius, so this is also 18 inches. So I need to get the area of the sector. And the area of the sector is going to be the fractional area of the circle. The fraction being the central angle out of 360 times pi r squared. Now, if I type that in, the 18 squared times 60 over 360, I get 54 pi. It becomes 1/6 times 324, which is 54. Then we get the area of the triangle. Now the triangle's pretty cool because I've got the two sides and the included angle. So I'm doing 1/2 or 18 times 18 times the sine of 60, all divided by 2, which gives me 140.296. And what I do is I subtract these two to get the area of the segment. So that's going to give me approximately 29.35 inches squared. So the segment is about 29.35 inches squared. Oh, it says to round to the 10th, 29.4. All right, do the next one. Try it on your own. Press play when you finish. All right, on this one, you've got 4 here. This is a 90-degree angle. So to get the area of the sector, you've got 90 out of 360 times pi r squared, which is 4 squared pi. And that's going to give you, this guy's going to be about, was it 12.57? I'm just going to round this. And then I need the area of the triangle. And the area of the triangle is going to be side times the sine of the included angle, all divided by 2. So 4 times 4 times the sine of 90, all divided by 2, which gives you 8. And I'm going to subtract these two guys to get the area of the sector. And so that gives me 4.57, which is about 4.6 meters squared. And that's how you find the area of a segment. Thank you for watching this movie.